Welcome to our CartPoleSimulator tutorial. CartPoleSimulator is a framework for experimenting with an inverted pendulum on a cart in a virtual environment. You can use it to test control algorithms before deploying them on a physical device. In this tutorial, I will guide you through installation and show you the basic functionalities of our simulator. But why the system is relevant? What are its dynamical equations, and how it looks in real life as a physical device in our lab? If you are interested also in these questions, necessarily check our Physical CartPole Quick Start tutorial. You will find there answers to these and many other questions. So, let's start. CartPoleSimulator is hosted at Github of Sensors.ini. You will find the link in the description of this tutorial. Let us now copy this link and set up the project in PyCharm. We click Get from Version Control, paste the link to our GitHub repository, and confirm that we want to clone the project. The next step is to create virtual Python environment. We do it through Interpreter tab, which we find at the very bottom of PyCharm window. We click Add Interpreter, go to Conda environment. As Python version, we set Python 3.8 and confirm our settings. When our environment is ready, it remains to install the required Python packages. They are all listed in requirements.txt file. To install them all, just go to terminal and run pip install -r requirements.txt. Let's first have a quick look into subfolders of our CartPoleSimulator. First subfolder is called CartPole. Indeed, it corresponds somehow to physical CartPole. The most important part is hidden in this CartPole model py file. You can find here ODEs governing the dynamical behavior of the CartPole. If you are interested to learn more about these equations, see our physical CartPole tutorial. GUI folder contains all functions necessary to create CartPole GUI, and others contains various scripts which are either obsolete or not yet fully functional, or just not relevant for a normal operation of CartPoleSimulator. You do not need to worry about this. Finally, the last two folders contain SI Toolkit, set of scripts we developed to facilitate training and testing of neural networks on collected data and integrating these networks into your controllers. For SI Toolkit, we have for you a separate tutorial. As the installation of Python packages has finished in the meantime, we are ready to play with our virtual CartPole. Let's just right-click on Run CartPole GUI and select Run CartPole GUI. And this is our CartPoleSimulator. You can see here visualization. Take care, it is not up to scale. Below you have an arrow with which you can set target position. And finally, you have a lot of options to set your CartPole simulation. Let us start our first experiment by clicking the Start button. We can now change the target position of the cart by hovering with the mouse over the lower field. We can also give a kick to the pole and see how the controller deals with such a disturbance. Finally, when we are done, we can click a Stop button and the summary of the experiment over time will be displayed. You can see the angle, position, motor power and position target over the whole duration of the experiment. Notice this peak corresponding to the kick we have given to the pole. Notice that after we performed our first experiment, new folder in CartPole project appeared, Experiment Recordings. This folder contains recordings of experiments with all the variables included. You can use these files for your system identification and training of neural networks. Let us now come back to the GUI. We can change the controller, let's say from doMPC_discrete to LQR. But where does these controllers come from? In fact, GUI is automatically searching the controllers folder and adds the files to the list if they follow naming and structure convention. You can have a look into template controller PY to get more information about this process. Let us perform a random experiment. It can be set through the radio buttons in the lower right corner. In this mode, simulator chooses the target position on its own. We also would like our experiment to run 3 times faster than real time. This can be set through speedup text box in a lower left corner. Let's set it to 3 and press the start button. We see that now simulator chooses various target positions over time. At any point we can stop the experiment and look at the experiment summary. Yet another way to facilitate data collection is provided with our data generator. You can use it to generate the same random experiments as in CartPole GUI, just now with maximal speedup and without unnecessary computational load caused by GUI. Let's try. We right-click on Run Data Generator PY and then on Run Data Generator. We see that now there's a series of experiments being generated. Let's stop it here. Finally, you can use the replay option of CartPoleSimulator to check that the generated data is what you want. Just set the replay mode with the radio button and copy the name of the CSV file containing the recording of interest into the CSV file name text box of CartPoleSimulator and press start. Again, at any point you can stop replaying the recording and plot the summary. That's it for our short CartPoleSimulator introduction. If you have more questions and to learn about many more available functionalities, check README, look into the code, or contact us directly. Check also our other tutorials from LTC21 series. We wish you many successful experiments with our CartPoleSimulator.